Well, hello everyone. Today our topic is going to be, as you can see, factoring polynomials. So we've got six things that we're going to cover inside that topic. And let's begin with the first one, which is common factors. Now, in the previous section, we looked at something like the distributive law. So for instance, if you had 3x squared, 2x take away 7, for example, and you multiplied these together, you would get 3x squared times 2x minus 3x squared times 7. And when you multiply these together, you would get 6x to the 4, take away 21x squared. So when you take an expression such as this one, and you use what we call the distributive law, you basically eliminate the brackets, expand the expression, and you're left with this. Factoring is the opposite process, which is essentially, suppose I gave you that guy. We want to put it back into this format. We call this process going from this expression to one that looks like two things multiplied. We call these things factors. Two factors multiplied. We call that process factoring. And it depends on what you get at the start, what they give you, how you're going to factor it. The ones called common factors, and this would be an example of it, would be that if you look at the terms, you can find numbers and various powers of x that they at least partially share. And we pull out the biggest common factor, and that's this bit here. And then we figure out what's left. So that's going to be our process to start with. So for example, if I said to you 3x squared minus 10x to the 4 plus 5x cubed. Well, the first thing I would look at is the numbers, and I'd see 3, 10, and 5, and there isn't any common factor, right? A common factor is a number that would divide all three of these without leaving the remainder. There's nothing that divides 3 that will also divide into 10 and divide into 5. These basically means there is no common factor numerically, at least apart from the trivial one of 1. But I do have an x squared, I do have an x to the 4, and I do have an x cubed. And what you choose in that situation is the smaller power of the three choices. So in this case, I'm picking x squared. And that guy we call the common factor, x squared. Then you take each term and essentially divide it by x squared. So x squared, 3x squared, you're left with 3. If you do x squared in this guy, you're going to get negative 10. You've got x to the 4, but you're going to use up 2 of them, so that gives me x squared. And this one, you're going to get a 5, and x cubed, divide by x squared, or if you want to say use up, which I use a lot, you get that, and there's your answer. Now, common factors can be single values. They can, like an x squared is like a single value, or you can get combinations of things. So how about 4x squared, 4b squared, I should say, 8b, and 12b to the 4. Now, in this case, 4, 8, and 12, the best number that I know divides into these without leaving a remainder, the biggest number is 4. And then I have a b squared, I have a b, and I have a b to the 4. Well, when you've got all of them contain a variable b, the one that's got the smallest power is the common factor. So together, the common factor of this expression is 4b. 4 gets used up, one of these gets used up, you're left with b. 4 into 8 gives you 2. B is totally used up, so you just get 2. And this one, 4 into that gets you 3. And use up one of these, you've got b cubed. And we have now basically a factor that is in common factors. First question that we have And the homework looks a bit like this. And this time we've added in one more layer. There's now two variables as well as a number. So we have x squared y to the 4, and we have 24 x y squared. So I'm going to look for common factors. Well, I have 24 and 4. Well, obviously 24 is too big. It doesn't go into 40. So I'll try 12. Well, that still doesn't go to 40. Next number down would be 6. That doesn't get to 40. The next number is 4. So I know that both of these work with 4. Now this has an x squared and this has an x, so I'm going to use x's. This is a y to the 4 and this is a y squared, so I'm going to use y squared. So this is a common factor, 4x y squared. Now 4 goes into 40 10 times. An x into that leaves behind 1x. A y squared uses 2 of these up, you get y squared. Now 4 goes into 24, gets you 6. The x is used up, so you don't write anything, and the y squared is used up. So essentially you're leaving 1 behind, but 6 times 1 is 6. And I'm having a quick look at that. And I've noticed, which will happen, that I can do a little bit better. Do you notice that there's a common factor of 2 here? So when I said 4, 8 would have been a better bet. So let's pull that one up. Common factor of 2, right? Leaves you with 5 of these guys. Plus 3. So when you're finished, always have a look in case you can do a little bit better. And it wasn't until I got there that I realized I could have used another common factor of 2. So if you pull out 2, you get this and this. 2 times the 4 that's already there gets me the 8. Right, another one. This is question similar to number 2. And we have got essentially to factor this expression. Well, I've got an 8 and a 16. I'm pretty sure 8 works for both of them. I have an x and an x to the 5, so I'm pretty sure x uses them. I have a y and a y to 5. Again, the smaller power is y. Now, 8 goes into 16, 2. This x uses one of them, so you've got x to the 4. This y uses up one of them, you've got y to the 4. Now the bit that sometimes gets people. 8 used up, x used up, y used up. The mistake people do is they think that that's 0. There's always a 1 left behind, even if you've used all the common factors up. And you can see why that needs to be there. 8xy times 1 will get you this term. So you need it. You can't just say plus 0 or just write nothing down. That won't do. That won't work. So let's try question 6. At least a version of it. So 28 x cubed y to the 4, take away 21 y to the 5. Okay, I can divide that by 7 and I can divide that by 7, so I'm pretty sure 7 is a common factor. This has got y to the 4 and this has got y to the 5, so I'm pretty sure y to the 4 is my common factor. This has x cubed and this doesn't have x's, so there is no common factor that uses x. So the common factor, the final common factor is 7y to the 4. Now, 7 goes into 28 4 times. There's nothing affecting the x cubed, so it's still there. Y to the 4 uses up that. Technically times 1, but we don't write the 1 in this case because we already have a 4x cubed. Take away 7 into that one goes 3. Y to the 4 using that up leaves me with y. And a quick check, yep, there's nothing more to do. I know that we are finished, and that is great. So the last one of this type I'm going to do is question 8. And it's basically got as much as you could possibly think. For starters, it's got 3 variables and a number. That's one of the issues. Secondly, there are 3 separate terms rather than your typical 2. And so we're now looking at that. Okay, let's take it one stage at a time. I have 14, I have 35, and I have 28. If I go through all the combinations that divide 14, the only one that works with all of them is 7. I'm going to look at the powers of x's. There's a 5 here, there's a 4 here, but there's none there. That makes x is not going to be any good to us. There's a y squared, but there's no y squared there, so y's don't matter. There is, however, a z cubed, and another z cubed. So when we have a choice, you always choose the smaller of them. And so 7z is our final common factor. 7 goes into this twice. That was not touched. The y squared was not touched, and the z's got all used up. Middle term. 7 goes into that 5 times. The x to the 4s were untouched. And z cubed, use up one of the z's, you get z squared. 7 goes into this guy plus 4. y5 is untouched. Z cubed divided by z. Use one of them up. There's your answer. And we are finished with common factors. At least straightforward common factors. I'm now going to move on to number 2, which are complex factors. And there are only 2 examples of this. They are still common factors, but they're not very obvious ones. They're not very straightforward. And so the 2 questions that do that are questions 7 and then eventually question 10. So here is question 7. 7 lots of x add y plus a lots of x add y. Now, normally you think of a common factor as being an x squared, a 42, something like that. But in this case, each expression has an x plus y in it. So I'm going to use x plus y as my common factor. Now, that gets used up, you get a 7. That gets used up, you get an a. And there's your answer. Now, the next example of that would be question 10. And we have x squared plus 7x plus 2x plus 14. Now what I'm going to do here is take out a common factor of x and take out a common factor of 2. And then I notice that both of these have x plus 7. And that leaves me with an x, and it leaves me a plus 2. And there we are finished. And that takes care of situation 2. Now we come on to the kind of what would I say? The major types of questions. So this is number 3. Topic 3, I guess. Factoring trinomials. And we would also call these quadratics. Now, the ones I'm talking about are trinomial means there's 3 terms, but the ones I'm essentially talking about are guys that look like this. 3 terms, an x squared, so many x, and a number. That's the main feature, right? A single x squared, or whatever the variable may be, plus or minus a number of x's, plus or minus a constant term. Now, there is a way to factor these. It's essentially the opposite of FOIL. Remember when you did FOIL, F-O-I-L, you eventually could get this. Let's see if we can figure out, and there is a rule for it. Since this is x squared, these 2 of an x. And then what you want to do is you want to focus on this number here. And you kind of ask yourself this question. Find two numbers which do the following things. First thing, when you multiply these two together, the answer should be 5. And the second thing is that when you add them, the answer should be 6. Well, if I think about two numbers that multiply together that give me 5, and when I add them, I get 6, it's pretty clear that the numbers are 5 and 1, both positive in this case. And that's the answer. Now, you can FOIL that out to check, but it does work. Now, before you start thinking that's far too easy, let's show you some issues that you have to be well aware of. Here's a very similar expression, a trinomial that they want us to factor. It's still going to be x and x. And we're looking for two numbers that multiply together that give me 5, but when you add them, you get -6. In this case, both numbers have to be negative. -1 times -5 gets you +5. And if you add these two together, you do get -6. Now, what can happen next is as we go through these questions, you're going to find that the combinations are just going to be a little bit trickier. So here's a random one. Here's question 12. It's going to be an a squared plus an a, take away 72. A squared means you have an a and an a. So I'm looking for two numbers that multiply together to give me -72. And when I add these two numbers, I get +1. Now, since this number is -72, that immediately tells me one of my numbers has to be plus and the other has to be negative. So if you think about it, I could do 1 and 72. Then I could do 2 with the, what would that be? 36. Then I could do 3. Can I do 3? Yeah, 3 times 24. And then I could do 4 times, what could I do? 4, 1, 18. I could do 5. No, 5 doesn't work. Could I do 6? Yeah. 6 times what? 8. Not 8. 6 times 9, 10, 12. 6 times 12. That would work. I cannot do 7 directly. I could do 8 times 9. And that's probably all, because all I would do then would go 9, 8 and climb back up again. Now, as I scan through these, and right now I've just got all the positive numbers, I know that one of them has to be plus and one of them has to be negative. And the only one that's really a good candidate for that is this one here, because the difference between them is 1. And since I want a positive number, I make that plus and that negative. So if you make that -8 and you make that +9, you FOIL that out, I guarantee you will get this answer. Now imagine I had almost the same question, but with one change. I made that -1. These are all my combinations. Now I know that there's no way you could add or subtract those two and get 1, or -1 for that matter, or 1, or 1, or 1, or 1. It's still this guy, right? But this time, that's going to be the plus, and this is going to be the 9, right? Negative. Because when you combine those two together, you get -1. So in this situation, that is your answer. Let's try another example. This one here is version 15. And in question 15, we are being asked to factor that guy. Now I know it's going to be a y and a y. That's the easy bit. I know that this is positive, so my two numbers have to be the same. Since this is negative 19, I know that the two numbers I'm going to do are both going to be negative. So I've kind of got as much information as I can. So I'm looking for two numbers that multiply together that give me 78, and when I add them, I get negative 19. Now, I could start at 1 and 78, but that's probably not quite as good. But for completeness sake, I'll do it, right? Those two would do the job. Right, if I move up, negative 2 and 39. Can I do 3? Yeah, I can do 3 then. And 3 goes with, what does 3 go with? 26. Not quite there. And can I do 4? Can I do 5? Can do 6. And 6 goes with 13, and I'm stopping there. You see, those two give me negative 19. So y take away 6, y take away 13, and we have done it. So you probably want your calculator handy and try all the different combinations that you can think of. 1 times this, 2 times this, 3 times that. Now you might have thought, what about 4 times something and 5 times something? I can show you why those are non-starters, because we want whole numbers. If you go 78 and divide it by 5, you see it doesn't come out as a whole number, so it's not a factor of 78. And if I do 78 and I divide it by 4, that doesn't work either. But if I do 78 and I divide it by 6, you see it does work. So we finished with that one. And what else can we do? Do one more, I think. Let's do 17. And 17, we have a squared take away 13a plus 40. So it's an a and an a. Two numbers that multiply together give me 40, but when I add them, I get negative 13. That tells me that I am definitely going to be using two negative numbers. And negative 2 gets me negative 20. And those two don't add up to negative 13, neither do those two. I guess the next one I've got is negative 4 and negative 10. That one doesn't work. I think I've got negative 5 and negative 8. And that one does work, because those two do give you negative 13. Now, you might come across a question which is impossible. I'll tell you what example of that. If you try to go through all the combinations of 3, you don't get many. And the ones that you get definitely don't add up to 14. That's because this thing is non-factorable. It means you cannot factor it. And if you get a question like that, you're probably going to get 1. That's what you write down as your answer, if it happens. Let's see where we're off to next. Right, now we're going to look at, that there should be 19 actually. Now we're going to look at factoring trinomials with 2 variables. So let's show you an example of that. That's question 20. And we have a squared, we have take away 7ab, and we have 6b squared. Now those kinds of questions are quite difficult to do, so I'm going to show you a little shortcut or trick that's very helpful. Imagine that the b was the number 1. Then this becomes a squared take away 7a plus 6. Now we know how to factor that guy. You can check it, but it's a minus 1, a minus 6, right? Then you take these numbers, and negative 1 gives you negative 1b, and negative 6 gets you negative 6b. Now, I don't normally do this because it takes time, but I'm actually going to prove that that, in fact, is the correct answer. I'm going to FOIL it. Here's if. A times A a squared. Now we're going to do the outside. Oh, and that's going to be a times negative 6b, which is negative 6ab. So here's your O. Going to do the inside now. And negative b times a is negative ab. Call that I. And then we do the last guys, that's these two. And do you get, well, if you do the a and the negative 6b, sorry, if you do negative, oh yeah, get distracted there. That's the last ones. If you do negative b times that one, you get plus 6b squared. Now the two terms in the middle are identical, so we can combine them. So the answer is a squared negative 7ab plus 6b squared, and you see, it works. Let's try one more of that type of question, where you're factoring a trinomial with two variables. So I'll pick 22. So we have an a squared, a 13ab, and a minus 48b squared. And we'll pretend that b was equal to 1, in which case I get that again. I can factor this one, at least I hope I can. 48, what did that get me? 4 times 12. 8 times 6. Ooh, that's a sneaky one. I wonder if this one is non-factorable. Let me check. So it's question 22. Just getting the answers from the computer. See what it says. Negative and that. So I'm going to be looking at, according to this one, negative 3 and plus 16. Let's check. Yep, they multiply to give you 48, negative 48. And if you add them together, you do get plus 13. So a take away 3, a plus 16. And then the negative 3 becomes negative 3b, and the 16 becomes 16b. And we are done. And so the trick, the shortcut of pretending that b is 1 and then factoring it, did the job. So we're now on to this topic, and this is factoring complex expressions. Now these are going to be the most difficult ones to do, and they start at question 23, so let me use that as my first example. It's going to be 6x to the 6, taking, subtracting 60x to the 5, plus 126x to the 4th. Now essentially what we're going to do is we're going to take out a common factor first, and then whatever's left, we'll see if we can factor it. So I'm looking at 6, 60, and 126, and I happen to know that 6 works for all of them. I have an x to the 6, a 5, and finally an x to the 4. So I'm going to do x to the 4. And that leaves me with an x squared. Take away 10x plus 21. And then this fella, this trinomial, can be factored. And two numbers that give me plus 21 when I multiply them, but negative 10 when I add them, are the numbers negative 3, negative 7. And that's that guy factored. Okay. So one more of these, let's say 25. we have 5x to the 6, take away 50x to the 5, plus 45x to the 4. I know that the common factor, as far as the numbers are, is going to be 5. And if you look at the powers of x, the smaller of the choices is x to the 4. Used up, x squared left over, minus 10, one of the x's left, 5 into that gets me 9, and that's all used up. And I have a quadratic. And two numbers that multiply together give me positive 9, but when you add those two numbers together, you get negative 10. The two numbers are negative 1 and negative 9, and we are finished. Those guys. So, the last group. And that is, how do you factor quadratics or trinomials of this form? Ax squared plus bx plus c. What we're talking about here is quadratics or trinomials where this number is not 1. So you've got 2x squared, 3x squared, 5x squared, right? That type of situation. And that involves a lot more trial and error. You really very often have to do a fair number of permutations before you find the right one. So here is 26 as an example. I need to factor 5x to the 4 plus 16x, add 3. Because this is 5x squared, I can make the sensible, reasonable assumption that this and this are 5x and x, because 5x times x is the only real way I can get 5x squared with whole numbers. We're not dealing with fractions or weird decimals. We are only dealing with numbers. Now, I have plus 3 here. So I'm looking for combinations of plus 3. There's only 1 and 3, but you have to remember in these questions to switch the order. Now, since the middle term is positive, that gives me a little bit of help. It means that both these are pluses. So technically, I've only got two choices. I can do plus 1 with plus 3, or I can switch the positions and do it in that order. Now, since there's only one correct answer, one of these must be the correct one, and the other one doesn't work. Well, if you do a quick FOIL on it, you'll have to trust me on it. This one doesn't work. There's your answer. Now, that was easy to do because there was only two choices, and one of them had to be the right choice, typically, and you just FOIL it out to find out which one is the right choice. That, unfortunately, isn't always going to be the case. So here is 27 to show you that you can get a lot more possibilities before you find the one that works. Okay, I want to factor that guy. Since this is 6x squared, I'm going to go 6x times x. But it might not work. If it doesn't work, my backup plan is to try versions that look like that. Now, I happen to know that, if I've got this right, that this version works. So that saves a little bit of time. Negative 40 means that one of my numbers is going to be positive and one of them is going to be negative. And if you think about 40, you've got that combination, and then you have to remember to switch places. And by that, I just mean, this time I mean change the sign. Now, if you switch places, of course, you get that. So out of just this combination of 1s and 4s, you see that there are 4 possibilities. None of them work, but you may want to check. So what's the next one going to be? Well, eventually you're going to get to 5 and 8. And it could be negative 5 and plus 8. Could be the negative 8 first and the plus 5 second. It could be +8 first and -5 second. If I go through all of these combinations, make this guy +5, and you make this guy -8. Now, if you FOIL this out, it works. And so you can imagine that it's going to be a lot of choices before you finally find the right one. So that's going to be an issue, right? You're going to have to work quite hard at getting combinations that work. Let's try 29. We have 5y squared, take away 18y plus 9. I know it has to be a 5y, that's good. Since this is +9, but that's negative, at least I know everybody is negative. Now, there's not too many ways of getting 9. And we know they're all going to be negative. Now, don't say, oh, that's -10, that's -10, and that's -6, and none of them work. You've got to remember that this that's by the way, that's one, that this guy here does affect the answer. So if I do that version, that's 1. If I do that version, or I could do that version. Now, one of these actually does work, and the one that works is this one. So if you FOIL that out, it doesn't match, and if you FOIL that out, but at least there was only 3 to try. Do 31. Well, in question 31, you have 5x squared plus 26x plus 5. And again, it's 5x squared, so that's something. And since this is +5 and this is positive, at least I know both numbers are positive. So if I go through the combinations of 5, there is 5 and 1, and then you switch the order. So that's it. So it's either put the 1 here and the 5 there, or you put the 5 there and you put the 1 here. And if you FOIL this one out and then you FOIL that one out, you'll find this one is the only one that works. And so you have your solution. Picking 32, which is almost the end, and we have a 4a squared, take away 26a plus a 15. And the reason I'm picking this one is that if you went through all the ways it could happen, and the most common ways are going to be 4a and a, and if that didn't work, you could try 2a and 2a. And there's lots of ways of getting 15, 1, but since these are negative, I at least know that the answer, if it's going to work, would all be negatives. And if I went through 1 and 15 and 3 and 5 and switched them, none of them work, because this is an example of non-factorable. So if you try and just nothing works, then you are looking at a non-factorable. So to finish, let's look at the last one. Now, if you're really lucky when you're doing this method, you will get the correct one, right? The one that works early on. And if you get one that works, stop. You've got the answer. There aren't going to be another one. You've got the only answer you need to worry about. Now, this one here is pretty horrible. And it doesn't work with the 10 times 1. It works with the 5 times 2. Now, this number is positive, but that number is negative. Whenever that happens, you know that both numbers have to be negative to generate a -21 in the middle, right? 2 negatives multiplied will give me 9. And eventually, if you FOIL this out, you'll get -21. So I have 1 and 9. I have 9 and 1. And then I have 3 and 3. And if we go through the combinations, the one that eventually works is this one. If you do a quick check, that guy is -15y. That guy is -6y. that gets you negative 21. The y squareds and the number are kind of guaranteed to work because of the way we constructed it. So you only really need to check the outside and inside, and if that matches that, you've got the answer. And that's basically it.